Assalamu alaikum and a very good morning to all. I hope you're doing well. Today we're going to be talking about our next chapter, which is from our book Secondary Chemistry. So it's our 1.4. We won't be doing as 1.3 because we are actually not concluding that in our syllabus for grade 5, 6, and 7. So we're starting with 1.4, melting, freezing, and subliming. So our objective for this lesson is name and explain changes of the state involving solids and describe how melting points can help identify substances. So I think we should get started with it. Okay, so first let's start with solid to liquid. Okay, so the change of state from solid to liquid is called as melting. When a solid melts, its particles move out of the regular pattern. So what happens actually in melting, that the pattern moves. Like in solid, the pattern is in a fixed position. There's a regular pattern. But when it's changing, when it's melting, the pattern is out. There is no pattern. It's an irregular pattern. So the particles start to move around in and out of each other. So the particles zoom out, they move out, they spread out. They are not fixed together, just like in solid. This means that the particles arrangement changes all the time. So the conclusion is that the particles change all the time whenever the substance is changing to the other one. The particles touch each other when the substance is in both its solid and liquid state. So the particles touch each other when they're in both states, solid and liquid. So it's equal. Okay, so next we will be talking about melting point. Okay, so over here I have made these two tables for explanation. Now over here you can see that this is the melting point and this is the boiling point. So there are two differences between these tables. The melting point and boiling points are different, and we have the substances which are the same, but the boiling point and melting point for each substance is different. Okay, so the different substances melt at different temperatures, as I just said right now. Boiling and melting points are different. So the melting point, as you can see, of nitrogen is minus 210 degrees Celsius, and the boiling point for nitrogen is minus 196 degrees Celsius. The temperature at which a substance melts is its melting point. So when the substance is melting at one certain temperature, that's known as its melting point. Every substance has its own melting point. As you know, that every substance has its own melting point and they cannot be melted at different substances' melting point. Okay, so let's talk about the next one, which is using melting points. How can we use melting points? Let's learn about it. Okay, so scientists use melting points to help identify substances. Like we use different stuff. Scientists also use melting points to help them identify the substances. Okay, so melting points are scientists' partners to help them identify the substances. Then, okay, now over here I have given you a type of question, but it's with an answer with it. So it's just a girl who has a white liquid. Her name is Sarah, and she has a white solid. So she wants to ask her our help to her to identify the solid, what that white solid is. So she has figured it out, she has concluded it, and she has seen the temperature by the melting points. So she heats the solid until it melts. Okay, so the white solid, she melts it and then sits until it melts. Then its melting point is 561 degrees Celsius. Then she uses a data book to find that one substance with this melting point is calcium nitrate. So as I showed you in before, there's a table where they were showing the melting points. But over here, she uses a different data book to find that the melting point, 561 degrees Celsius, is for calcium nitrate. Then she concludes that her white solid might be calcium nitrate, but she's not really sure yet that it is. She did not do the prediction, then she did not say the final results. So she just concluded right now. She decides to do further tests to make sure. So what she does for further tests, she repeats the investigation to make it a fair test. And then if she is done with it, then she concludes it and then her prediction is correct. Then melting temperature also tells you about the purity of a substance. So as you know, what actually happens is that melting temperatures can also tell us the purity, which means the purity means that if it's the exact same substance, if it is not chemicalized or if it is not mixed with different types of chemicals. So then it says, if a substance has a sharp melting point, it is not mixed with anything else, / it's a pure substance. So if it has a very good melting point, if it's the same melting point as, for example, water's melting point is 0 degrees Celsius, and if water melts at 0 degrees Celsius, then it means it's a pure substance. But if water's melting point is 0 degrees Celsius, and then if its temperature is different, if it melts at -12 or maybe 12, then it means that there are chemicals inside the water, and we should not drink it because that's harmful for our body. Okay, so now let's learn about liquid to solid now. Okay, so over here I have added a photo. So this photograph shows ice crystals forming from liquid water. The photograph was taken in a polarized light. So as you know, we usually add ice to make our water cold, right? So there are crystals inside ice. So this is the photo taken from the polarized light. Okay, so the change of state from solid to liquid is called freezing. So as I showed over there, that freezing and melting are the opposite. Freezing is the opposite of melting. So the change from liquid to solid is freezing. Solid to liquid is melting. Then when a liquid freezes, its particles stop moving around from place to place. Okay, so this is the exact same opposite. Now, when a liquid will freeze, its particle will stop moving around from place to place. So what actually happens is that the liquid, when it freezes, freezing is when the particles stop moving, but in melting, the particles start moving. Then they arrange themselves in a regular pattern and vibrate on the spot. So as I told you in the before slide as well for melting, that in melting they do not arrange themselves in a regular pattern. There's no regular pattern in them. So it's the exact same opposite. Like over here in freezing, the particles stop moving, and in melting, the particles start moving. But again, in freezing, the particles have a regular pattern and vibrate on the spot. But in melting, the particles are not having a regular pattern and do not vibrate on the spot. So freezing and melting are different, 100% the opposite. So the temperature at which a substance freezes is its freezing point. Every substance has its own freezing point. Okay, so this might get a bit confusing, but over here it says freezing is the opposite of melting, right? But freezing point and melting point is the same. This is a bit tricky part where it comes as many kids get difficulties in their head that how is it like that? But it's a chemical reaction which happens with different types of chemicals and substances. So the freezing is opposite of melting, okay? But the freezing point of a substance is the same as the melting point. So don't get this wrong. Keep this in your brain, okay? For example, I gave you an example over here as well. O stands for example, okay? So the freezing point of water is 0, right? And the melting point of water is also 0. So it means freezing point and melting point is the same. But freezing is the opposite of melting, okay? Now let's learn about the next one. It's sublimation. Now, as you know, sublimation is a new word for this grade level for Y5, 6, and 7, but I might be explaining this as well as it is in our syllabus. Okay, so most solids melt to form liquids when you heat them, but some solids do not change state to become liquids. Instead, they become gases. The process is called sublimation. So what actually happens over here is that instead of becoming solid to liquid, it becomes solid to gas. It doesn't go to liquid form. It doesn't go. It goes straight from solid to gas. Okay? So this process is called sublimation. Let's see how it happens. A solid sublimes when it changes directly into gas without first becoming a liquid, as just I told you. Now over here is an example. This is a very common example. I guess many of you have seen it as well. In stage shows or rock concerts, this solid carbon dioxide is used, which is also the other name is dry ice. So if you keep solid carbon dioxide aside and wait patiently, the solid will start turning into gas. Because it's carbon dioxide, it's joined together, the particles are squeezed together, but then they start going around, start roaming around. And over here is solid iodine, solid gray iodine, so it's solid over here as you can see. But when it gets dried, when it cools, it turns to solid again. But when it's heated, the gas starts to went away. It starts to go. It starts to explore. So now over here, I am actually finishing my lecture. So these are some trick questions. I hope you can answer them. These are 3 questions, and I guess they're very easy. They're related to the thing. Okay, so please use your brain and do not do any cheating from Google or anywhere else, because this is the only 3 questions I gave. I could have given more, but I thought giving 3 is much better than giving 4 or 5. So these are very easy, and they're just from the chapter, so you can note them down if you like, and they're super easy. Okay, so now we will be talking about what we have learned today. These notes are very important. If you like, you can even take screenshots or write them down for our whole lecture. These are the 4 main points for the whole 5 to 6 sides. Okay, a solid melts to become a liquid. A liquid freezes to become solid. Some solids sublimate to become gases. Every substance has its own melting and freezing point. Okay, so now over here, as you can see, these are the 4 points I have been telling you in the before slide. So if you like them, I hope you like them, and I hope you understood my lecture today very well. Thank you for listening to me. Now I just have a little favor for subscribing. Please click the subscribe button and become one of these scientists, just cute as you are, and click the bell button. And I hope you've learned good, and I hope you enjoyed watching my presentation, and I hope you learned well. And don't forget to subscribe and click the little bell button to get notifications. Bye. Have a nice day. I hope you enjoyed it, and I was looking as forward as